Okay, this is for section 4.5 on completing the square. The first thing this author goes through in this section is what they call the square root property. And you can solve equations by using the square root property, or you can solve by factoring. Okay, the square root property says for any real number n, if x squared equals n, then x equals, basically what they're doing is they're going to take the square root of both sides. So you'd have x equal, which we actually used this property at the beginning of the chapter. And you take the square root of both sides, and x equals positive or negative n. So we did that on some of the homework. Okay. The author will ask you to solve using the square root property. But you can actually solve them by factoring also. So, an example on this one, say they give you x squared plus 14x plus 49 equals 64. By using the square root property, what they would do is they would have you look just at this much and factor just that much. X squared is a perfect square of x, 49 is a perfect square of 7. If you multiply them together and double it, you get that middle term, yes. And this is the sign inside. So you can factor that trinomial square back into the square of a binomial. And then, how do you get rid of the square? Square root both sides. So that's where they're using the square root property. If you square root that, all that's going to do on the left side is just get rid of the square. But you have to, on the right side, say that's positive or negative 8. Now there's two answers there. If you subtract 7 on both sides, because remember, if it's an x squared, you got to have two answers. So the two answers are 8 minus 7 would give you 1, or the 8, negative 8 minus 7 would give you a negative 15. So your two answers should be 1 or a negative 15. Okay? What's up? When you factor this back into x plus 7 squared, if you FOIL, you can either FOIL it or you can use the shortcut. If you FOIL that back, here's the x squared plus 7x plus 7x. There's your 14x plus 49. Okay? Okay, so we're just taking trinomial squared. This is a trinomial square, and factor it back into the square of a binomial. Okay? Let's try another one. Say they give you x squared minus 10x plus 25 equals 12. Two ways to work it. You could subtract 12 on both sides, get it in standard form equals 0, and factor it. But if you look and recognize on the left side, that is a trinomial square. X squared is a perfect square of x. 25 is a perfect square of 5. And if you multiply those two together, be 5x and double it, do you get the middle term? Yeah. So this is a trinomial squares. So, and this tells you the sign inside. So you can factor that back into the square of the binomial x minus 5, quantity squared equals 12. Okay? So we're just factoring the trinomial square back into the square of a binomial. Now take the square root of both sides. That'll just get rid of that square. So you'd have x minus 5 equals. What you have to remember on the right side is to do positive or negative. Square root. And square root of 12, largest perfect square inside? 4. And out of that we can take out, so you'd have plus or minus 2 radical 3. Now add the 5 to the other side. So you'd have x equals 5 plus or minus 2 radical 3. Okay, now that's the simplified radical form. And on the homework, I want you to do both, the simplified radical form, and then the author takes it an extra step. It says find it to the nearest tenth. Okay, so everybody grab a calculator. Okay, so I think on the book, like they want it to decimal form too, but I want the simplified radical form first. Okay, and then we have two answers there. There's one answer that says x equals 5 plus 2 radical 3, or x equals 5 minus 2 radical 3. So on your calculator, put in 5 plus, put in 5 plus 2 square root of 3. And then if they said nearest hundredth, what, 8.46, you agree with that? Okay. And then if you don't want to type in the whole thing, you could just do second function entry and then go back in and change that plus sign to a minus sign. So you'd have 5 minus 2 radical 3. And if they said nearest hundredth, 1.54, right? So I want to see both the simplified radical form and the decimal form. Okay? Okay. On the next part, the next type of problem, they're going to change the directions and say find the value of C. Find the value of, and they're using the letter C, that makes each trinomial a square. We want a trinomial square. I'm gonna take you back. The problem is like this: x squared plus 16x plus c. I want to go back and review just for a minute. We talked about a little bit up above there. If you have a plus b quantity squared, that's a binomial squared. Shortcut is square the first one, multiply them together, ab and double it, be 2ab, and then square the last one. If they have a minus b quantity squared, square the first one, multiply them together, a negative ab and double it would be a negative 2ab, and then plus b squared. These are the trinomial squares. Now, they will give you something like this. I'm just going to make up x squared plus 10x plus c. Okay? To go back the other way, if I said on this middle term, if they give you what this coefficient is, take half of 10 would be 5, and then square it to get that last. So then you'd have x squared plus 10x plus 25. Is that a trinomial square? Yeah. So if they give you this linear term, take half that coefficient, divide it by 2, and then square it and get your c value. So over here, what's this c value going to be? Yeah, because take half of 16, would be 8, and then 8 squared would be 64. So your c value, to make that a perfect square, is 64. If I turn this around over here, I'm going to change the letter. Say I said this was kx, and I wanted to know what this was. Give me a perfect trinomial square. Go the other way. They gave you the 25, so take the square root of 25, would be 5, and then double it to get the k value. Okay? So it makes a difference whether they give you the middle term or the last term. If they give you this term, take the square root of it and then double it to get the k value. So the k value would be 10 on that one. Okay? Okay, so let's try another one. Say they give you on column 4 x squared plus 12x plus c. Okay, so what's the c value? 36, right? Take half of 12 would be 6. 6 squared would be 36. So your c is 36. And check it. If you had x squared plus 12x plus 36, what's that factor back into? X squared is a perfect square of x. 36 is a perfect square of 6. If you multiply them together and double it, you get that middle term. Yeah, this tells you the sign. Okay, so it is a perfect trinomial square. Okay, now we're going to use that idea on trinomial squares. We're going to complete the square. We have so far, you should know 2 methods so far to solving a quadratic. You should know factoring to solve a quadratic, and you should know quadratic formula from last year. Now we're going to go through completing the square. Did you do completing the square in Algebra 1? I would guess probably not. Okay. Okay, so it is another method to solve a quadratic equation. And it's important that you know the terms. A quadratic equation's in this form: ax squared plus bx plus c equals 0. We talked about this at the beginning of the chapter. This, when I use the terminology, that is the quadratic term. The squared term is the quadratic term. The one that's an x to the first, that one is the linear term. And the c is just a constant. It's just a number. Okay, with that in mind, I'm going to go through the steps, and then I'll take you through a couple of examples. So these are the steps to complete the square. And when we use that phrase to complete the square, what you're really doing is you're making a trinomial square. You're creating a trinomial square in the middle of each one of these problems. Okay. First, most of the time it's going to be in standard form equal to 0. So most of the time you're going to have the equation's going to be in the form ax squared plus bx plus c equals 0. Second step, you divide by a on both sides of, and just use the equal sign. You divide by a on both sides of the equal sign. Step 3, get the constant term. Okay, get the constant term by itself on one side of the equal sign. Okay, get the constant term by itself on one side of the equal sign. Step 4, add the square of half the coefficient, spell it right. Add the square of half the coefficient of the linear term both sides. I mean both sides of the equal sign when I'm saying that. Okay, what that just did was that created a trinomial square on one side. Factor, and I'm assuming it's on the left side. Factor the left side, which is the trinomial square. Factor the left side, or the trinomial square, into the square of a binomial. So now you've got a quantity squared. So to get rid of the square, take the square root. Take the square root of both sides. Okay, then you have to simplify it. Remember, you can't leave any perfect squares inside radicals. You got to simplify your answer. Okay. Okay, let's go through an example. And they will say solve by completing the square. And if you were taking this on a test, you could also check it by quadratic formula. You could check it by factoring. This is just another method to solve. Okay? And let's say they give you 3x squared plus 10x minus 8 equals 0. Okay, it's already in standard form, equal to 0. Next step, divide by a, and this is our a is 3. So divide all the way across by 3. That 3 divides into, this is a polynomial over a monomial. That 3 divides into all of them. So it's x squared plus 10 over 3. And if you use a diagonal fraction bar, I would switch to a horizontal. 10 over 3 x minus 8 over 3 equals 0. Get the constant term on one side by itself. So it's minus 8/3, so do the inverse, add 8/3. And if you're at that stage where you can just do it by sight, then do it by sight. If you need to write it down, write it down. Some of you are ready to do it by sight, so go ahead and save yourself a step. So you'd have x squared plus 10 over 3x, leave a space, equals 8/3. Next step says take half the coefficient of the linear term. Half the coefficient of the linear term. Half of, what's of mean in math? Multiply. So half of 10/3. Okay? And don't be afraid to do the scratch work out at the side. Don't do the scratch work in the middle of the problem. Do it outside. Okay, and reduce. 2 would divide into 10 5 times. Multiply across on the top. Multiply across on the bottom. I get 5/3. Add the square of that to both sides. You got to keep it balanced. So add the square of that to both sides. What we've just done is we have made this a trinomial square. X squared is a perfect square of x. 5/3 squared is a perfect square of 5/3. You multiply them together and double it, you get 10/3. This tells you the sign inside is plus. Okay, now the right side, I still simplify it out at the side. So 8/3 plus 25/9. You square the top and you square the bottom. So common denominator is 9. So this fraction stays the same. You have to multiply the 3 by 3 to get 9. So multiply the top by 3. 24 ninths plus 25 ninths would be 49 ninths. Okay? And now how do I get rid of the square root both sides? And extend that radical out. Okay, when you square root that, all that's going to do is get rid of that square. So you have x plus 5/3 equals. Now, when you take the square root of both sides, plus or minus. You have to do plus or minus. And out of the 49, you can take out 7. Out of the 9, you can take out 3. Now, same thing. Those of you that are ready, just subtract 5. Like I would take the 5/3 over. So it's a negative 5/3 plus or minus 7/3. Now, there's two answers there. It's negative 5/3 plus 7/3. So that would be 2/3. The other answer is negative 5/3 minus 7/3. Negative 12/3 would be negative 4. So there's two answers, 2/3 or negative 4. Okay, so let's go back up through the steps. Standard form equal to 0. Divide by a on both sides. What happens if they give it to you? What happens if they give it to you in this form? Do you have to get it in standard form equal to 0?
No,
it's already there. So divide by. You could divide by a on both sides right there. Yeah. Okay. Okay. Let's try another one. Last example. 3x squared minus 2x plus 1 equals 0. Okay, it's already standard form equal to 0. Divide by 3 on both sides. That's a polynomial over a monomial. That 3 divides into all of them. So it'd be x squared minus 2/3 x plus 1/3 equals 0. Take the constant term over to the other side. So you'd have x squared minus 2/3 x, leave a space, equals a negative 1/3. Take half the coefficient of the linear term. Hang on. Take half the coefficient of the linear term. Half of that would be negative 1/3, and if you add the square of that to both sides, no matter what the sign is, when you square it and add it, it's going to be positive, right? So add 1/3. Wait, did I add the square of it? No, sorry. Yeah. Now add it. So I'm going to add 1/3 squared to both sides. But if you square it, yep. It's okay if you put a negative 1/3 in there and square it. It's going to be positive, right? So x squared is a perfect square of x. 1/3 square. I guess I should say no. It's 1/3. I'm going to take that back out. It's 1/3. So 1/3 squared is a perfect square of 1/3. Yeah, you need that to be 1/3. And this tells you the sign inside is minus. Equals. Now do the right side. Negative 1/3 plus 1/9. So this would be right. So negative 2/9. Right. Take the square root of both sides. So you'd have x minus 1/3 equals positive or negative. Now I split this up. Okay. Negative 2 is -1 times 2. So out of this I can take out an I. Out of this in the denominator I can take out a 3. So I have x minus 1/3 equals positive or negative I radical 2 all over 3. Now add 1/3 to both sides. So you get x equals 1/3 plus or minus I radical 2 all over 3. It's okay if you write it that way. Some of you will write it together, 1 plus or minus I radical 2, and it's all over 3. Those are both correct. Okay? Let's go back up here for a minute. When you have to have that, when you take the half the coefficient of the linear term, and then add the square of that to both sides. Yeah. So when you square it, it's going to be positive. Okay? Okay? So final answer, you can write it like this, or you can write it all over one denominator. Okay? But all of these, when they say completing the square, what that means is you're completing and making every one of those a trinomial square. As soon as you do this and add the square of that on both sides, you've made that a trinomial square. You can check answers by factoring, or you can check answers by quadratic formula also. Now, I think on the homework it says nearest hundredth, but I want to see the work to get to I want the simplified radical form and the nearest hundredth. Okay? Okay? Okay, give you time to work.